Welcome to the session on sketching a gradient graph. So given the graph of y is equal to f of x without its equation, just we have the shape of f of x, we need to sketch the gradient graph. So before we just do this, we need to have a recap of understanding the gradient connected with derivatives of calculus. So let us see how derivatives are connected with the gradient of a graph. If I just take a curve, say y is equal to f of x, then the gradient of this graph is geometrically understood as the gradient of its tangent. So if I just take the tangent drawn at some point, then in this case, this being the tangent would give me the gradient. So the gradient of y is equal to f of x is the gradient of the tangent, so slope. So this is how f dash x or dy by dx is understood geometrically. So this concept of slope connected with y is equal to f of x in terms of its derivative is what leads to understanding how to sketch a gradient graph for a given graph y is equal to f of x. So let us now check for the positivity or the sign change of the gradient. If imagine I had a graph something like this, and I have a graph something like this, then let us see how things work. So let me take the four cases out here. Downwards, these are the four possibilities in the branch of math where the graphs have different shapes. So these are the four types of shapes you can have when you break up the graph into different parts. Concave up, concave down, ever increasing, first concave down and concave up, and then ever decreasing, first concave up and then concave down. So let us see how the gradient changes for this. It is assumed that for a concave up curve, the slope, the graph is decreasing down here and the graph is increasing up here. And for concave up, we see that the graph is increasing first and then halts here for a while, it pauses for a while and then decreases down here. But let's see the third case. We see that the graph increases but pauses for a longer time out here and then again increases out here. Coming to the fourth case, the graph is decreasing and then pauses for a longer time out here and then decreases here. This pauses more because the flatness is more, implies the graph pauses for a more time, is how we understand. Anyway, we just look into the gradient. So what I'll be doing here is I'll just look into, for a decreasing curve, we know that the slope is negative. So this part of the graph will have slope negative. And next, the graph halts for a while here. That means the graph doesn't have any gradient. Slope is zero because the tangent at this point being f dash x is parallel to x-axis and therefore the slope must be zero in this case. And next after this it is increasing, so obviously the slope would be positive. And here, increasing curve, slope positive, pausing for a while, slope is zero, and decreasing, slope is negative. In this case, slope is positive, or I would just say simply if I say slope positive, plus 0 plus, minus 0 minus, minus plus, plus minus. So these signs make me understand that if it is plus, then the slope is positive and the graph is increasing. And if the slope is negative, the graph is decreasing, and then the slope being negative out there. Similarly, plus plus, ever increasing, pausing for a longer time, and ever decreasing is how the graphs look in four different cases. Now these are the concepts which help us in understanding how to sketch the gradient graph. So let us see how these concepts would help me with the slope of tangent of a curve y is equal to f of x being f dash x would help me in the key aspect of graphing a gradient graph. Coming to the next page, I would just take an axis. This is y-axis, this is x-axis, and then I have my x, my y. Now let me take an example graph and let us understand how this gradient graph is drawn for this. Interestingly, let me take a graph something like this. I hope this would be something like a cubic graph. Anyway, this is the shape, but interestingly, I don't know its equation, so I'm just going to represent this with it's some random shape. So I just take this as y equals f of x. Now, if I want to draw the gradient graph of this, the question is about sketching y is equal to f dash x, the gradient graph of f of x. So in this case, let me also take some key points like I know my x-intercepts. So for example, this is -3, this being origin, and this is 1, and this is 4. Let this be, let me just give this as -1, 4, some point out here. And let me give the point here as some 5/2 and something like -2. Yeah, fine. Okay, now let me mark them as A and B. Now you have enough information for the graph. The shape of the graph is given. There are max point. The max point is A, the minimum point is B, and the x-intercepts are -3, 1, and 4. Now let us take this valued information into sketching y is equal to f dash x. Now, the first thing we need to understand is if this is y equals to f of x, then my x-axis would be x and my y-axis would be y. So same way, if I graph y is equal to f dash x, my x-axis would be x and my y-axis would be dy by dx because my y is f dash. So this changes to f dash. In the sense, let me take another axis to sketch the gradient graph, but this time the axis would change. Now here I would get an x-axis, but I would get a y dash because I'm looking at f dash x being f dash x. I hope you understand how the y-axis changes. The whole of y-axis is now the slope. So this whole of y-axis is a slope. So let us see how it works. Now revisiting the previous concept of these 4 cases, case 1, case 2, case 3, or case 4, with minus plus, plus minus, plus plus, and minus minus, with increasing and decreasing. Let's try to connect that to this problem. The graph is first increasing up to here, and then halting, and then decreasing down here till it reaches 5/2 or 2.5. 5/2 is 2.5, and then it halts again, pauses by, and then increases. Therefore, I first have my slope, which is positive, then equal to 0, then negative, then equal to 0 here, and then positive here. So this is a situation where you get plus 0, minus 0, plus. So let us see how this connects to the graph. Now I'm talking about the slope. Initially, the graph until -4 has the slope positive. That means for positive slope, that means the graph is above x-axis because slope is positive. This region, slope is positive because f dash x is positive values on the top above x-axis, and slope is negative in the points below x-axis. It's just like this. We have plus all positive x values, negative x values, positive y values, and negative y values. In the same way, Here it is positive x, negative x, positive dy by dx or f dash, negative dy by dx. This is the concept through which I'm going to graph y dash is equal to f dash x. So let me take one more axis to just make this graphed. Now I will take a graph in the sense I just take this and then I take x-axis, y-axis, which is y dash. Now increasing slope is positive, that means the graph in this region will be above x-axis. It cannot cross below x-axis in the case of this axis. I'm talking about in terms of this axis. Yeah, the graph is above x-axis in x, y dash system, and the graph will have turning point. Slope is 0, that means it should have a turning point. This point is called turning point where the slope is 0. So wherever the graph turns, you have turning point. So you get a turning point. Then here it will be below x-axis and so on and so forth. So you have below x-axis and turning point and above x-axis. So let us see how it works. So at -1, there is a turning point. That means the graph is above x-axis. The graph is above x-axis. Let me use another color. Yeah, the graph is above x-axis and it is up to -1. Slope is 0. And then in this case, the turning point would be the x-intercept, because the turning point here turns to x-intercept because the slope is 0. So slope is 0 throughout x-axis. So f dash x is 0. Any point you take in x, y dash system, this represents x and slope. So when I say x and slope is 0, that means it's a point on x-intercept. It's nothing but an x-intercept. This would be nothing but a point on x-axis. So slope 0 refers to an x-intercept in case of gradient graph. And it represents a turning point on y is equal to f of x. So very simple. When slope is 0, it's a turning point on y is equal to f of x, and it is an x-intercept in y equal to f dash x. So this becomes an x-intercept, and after this we have a graph below x-axis until it reaches to the next x-intercept, which is here. So this next x-intercept comes out here at 2.5 because slope is 0. So this has to go until 2.5. And after reaching to 2.5, then again the graph goes to the positive side because positive means again above x-axis. So if I just look this above x-axis, then it has to go something like this. So I have a point here fairly being 2.5. Now this is just how we sketch the gradient graph, but it's not an approximate graph because you don't know its exact point. So I don't know what its point is. So you can have just a rough sketch, but not exactly the graph drawn. Similarly, you can also draw f double dash from this. If I want to draw y is equal to f double dash, then I take this graph and use the same gradient concept to graph, and so on and so forth. And so on is how the gradient graph works. Sketching the gradient graph from the given graph y is equal to f of x using the slope of the tangent of f of x concept being f dash x. Thank you.